Okay, so we have here example 2.6, determine the reactions on the beam shown in the figure. So, kung titingnan natin dito, we have fixed support, and this is a cantilever beam. We have here the AX, we have the reaction AY here, and we have the moment in A here. Now, since we have 3 reactions and only one member, so 3 is equal to 3, this is statically determinate. So, in order for us to solve for the reactions, ang gagawin muna natin ay hahatiin muna natin itong beam na to. So, isosolve ko siya ng tatlong paraan. Una, I have to divide this into a rectangle and a triangle. So, in here, we have our reactions, AX, we have here AY, and we have here the moment in A. So, kung titingnan natin dito, sa ating rectangle, we have the magnitude of 5 kilonewton per meter. So, meaning, this is 5 kilonewton per meter. And for the total, since yung total na magnitude ng load natin dito sa side na to is 15, so yung para kay triangle, this is 10 kilonewton per meter. Hindi lang halata sa drawing. Para sa resultant ng load natin dito sa triangle, it will be acting at 1/3 of the distance. So, that is 12 divided by 3. So, meaning this is acting at 4 meters. So, for the magnitude, we have to compute for... So, for the magnitude, we have to compute for the area of the triangle. So, magkakaroon tayo ng 1/2. The base is 12 and the height is 10. And this is equal to 60 kilonewton. And for the rectangle, gagawin lang natin ay magkukompute tayo ng area. And that area is just the base 12 multiplied by the height 5. So this is also equal to 60 kilonewton. And this distance where our resultant is acting, that is half of the span length, that is 6 meters. If we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, as you can see, wala naman tayong ibang horizontal forces maliban kay AX, so therefore your AX is equal to 0. And if we are going to summate forces vertical is equal to 0, taking the upward direction as positive, then we have the AY, since we assume that AY is directed upward, so therefore it is positive, minus yung resultant ng triangular load natin, that's 60 kilonewton, minus yung resultant ng rectangular load natin, that's 60 kilonewton, is equal to 0. Therefore, AY is equal to 120 kilonewton. So, since positive yung lumabas na sagot, so ibig sabihin, our assumption for AY na directed upward is correct. Okay. In order for us to solve for the moment at A, so we just have to summate moment at A is equal to 0. So, taking the clockwise direction as positive. So, since ang assumption natin sa MA natin is counter, so therefore negative MA. And for the resultant of the triangular load natin, 60, that will produce clockwise rotation. So therefore, that's positive 60 multiplied by the distance 4 meters. Para sa resultant ng rectangular load natin na 60 kilonewton, that would create a clockwise rotation also. So plus 60 multiplied by the distance of 6 meters, that is equal to 0. So solving for the value of the moment in A, that would give us 600 kilonewton meter. And since positive yung lumabas na sagot, ibig sabihin tama yung assumption natin that the moment in A is counterclockwise. Okay. For solution number 2, what we are going to do is to divide this into two triangles. So gagawa ako ng dalawang triangle. For solution number 2, ang gagawin ko ay hahatiin ko to into two triangles. So we have here a triangle with the magnitude of 5 kilonewton per meter here and 15 kilonewton per meter here. And meron tayong reactions at the support, of course, that is the AX. We have here the AY, and we have the moment in A. So, para dito sa triangle na nasa left side, yung resultant nito is just the area of the triangle, or if the span is 12 meters, this would give us our area 1/2 12 times the magnitude of the load 15, that is equal to, so that would give us 90 kilonewton, and it is acting 1/3 of the distance, so meaning 12 divided by 3, this is 4 meters. Para naman sa load natin on dito sa triangle natin sa right side, the resultant will be acting at 2/3 of the distance ng base ng triangle na to. So meaning this is 8 meters. For the resultant of the load, it is just the area of that triangle. So we have 1/2, the base is 12, and the height is 5. And this would give us 30 kilonewton. If we are going to solve for the value of the AY, we have to summate forces vertical is equal to 0 and taking the clockwise direction as positive. AY is directed upwards, so that's positive. Minus 90 minus 30 is equal to 0. And AY is equal to 120 kilonewton. Since positive yung lumabas na sagot natin, therefore it is directed upward. And if we are going to summate forces horizontal is equal to 0, taking the direction to the right is positive, wala tayo nakikitang horizontal loads natin, so therefore AX is equal to 0. And if we are going to summate moment at point A, that is equal to 0, taking the clockwise direction as positive, we assume that MA is counterclockwise, so that's negative moment in A. And for the 90 kilonewton resultant load of the left side na triangle, will create a clockwise rotation, so that's positive 90, multiplied by the distance to A, so that's 4 meters. And the 30 kilonewton will create a clockwise rotation also, that's plus 30, multiplied by the distance of 8 meters is equal to 0. And our moment in A is equal to 600 kilonewton meter. We assume that our moment in A is counterclockwise and positive yung sagot natin, so therefore this is counterclockwise. If we are going to compare our answer with the previous solution, then we can see that our answer is the same. If we are going to apply the idea of the centroids, hahanapin natin yung centroid ng trapezoid na to at doon natin i-apply yung load natin. So, hahanapin natin yung centroid ng trapezoid na to at doon natin i-apply yung load natin. And ito ay tatawagin nating area 1 and this is area 2. So, sa area 1, we have here the 60 kilonewton and yung ating x1 is equal to and our x sub 1 is equal to 4 meters. And for the area 2, we have here 60 kilonewton and the x sub 2 is equal to 6 meters. Now, for the area total, we have here 60 plus 60. That would give us 120 kilonewton. So applying the idea of the variance theorem, so we have the area total x bar is equal to the summation of AI xi. So we have here the area total multiplied by x bar that is equal to summation of the area, the product of the area and the distance x to the centroid. So that's a sub 1 x sub 1 plus a sub 2 x sub 2. So area total is 120 multiplied by x bar is equal to 60. X sub 1 natin is 4 and area 2 natin is 60 and the x sub 2 is 6. So that would give us x bar that is equal to 5 meters. Anong ibig sabihin nito? Ang ibig sabihin nito, if this is our cantilever beam and this is our trapezoidal load, the resultant of the load, which is area total 120 kilonewton, that is acting at x bar equal to 5 meters. Now, for the reactions, we have here AX, we have AY, and this is moment in A. So, summation of the forces horizontal is equal to 0, taking the direction to the right as positive. AX is equal to 0. Summation of the forces vertical is equal to 0, taking the upward direction as positive. We have AY positive kasi we assume that AY is directed upward. Minus 120 is equal to 0. So therefore, AY is equal to 120 kilonewton. Since positive yung lumabas na sagot, therefore, tama yung assumption natin that AY is directed upward. If we are going to summate moment at point A is equal to 0, that is, we assume that the clockwise rotation is positive. Negative moment in A because we assume that moment in A is counterclockwise, plus 120 multiplied by the distance of 5 meters is equal to 0. So solving for the value of the moment in A, that would give us 120 times 5, so it's 600 kilonewton meter. Since positively lumabas na sagot, then tama yung assumption natin that moment in A is counterclockwise. Now, if we are going to compare our answers sa sagot natin kanina, then pareho lang yung sagot natin.